My today's topic is capacitors in parallel as derivation. I'm having the three capacitors of different capacitance: capacitance C1, capacitance C2, capacitance C3. And if they are connected, like first plate of each capacitor are connected, is each plate of all the capacitors are connected at one point at here, and second plate of every capacitor, each and every capacitor connected to the second point here, then they are said to be, this arrangement is called capacitors in parallel, and shown like here. This is first capacitor, okay, first plate and second plate, and second capacitor, these they are connected here, okay. Then third capacitor, first plate of third capacitor, second plate of third one, okay. Now C1, C2, C3, so they are said to be in parallel, right? Now what we are doing, giving some potential. Now this plate is going, we are going to connect this plate at the earth potential, like that here may be connected to the earth potential. Now here the potential difference between this point and this point, let it be V. Now first of all, what is the definition? Capacitors in parallel. The capacitors are said to be connected in parallel between the two points. Listen carefully and you write the definition as it is in the exam. If we proceed from this point, one point to the another point, if we can proceed from this point to this point along the different paths, mean we can proceed along this path, along this path, along this path. If we are having the different paths from one point to the second, then the capacitors are said to be connected in parallel. This is the definition, and keep in mind now. Now because the potential difference is applied, here some potential difference is applied. Okay, potential difference is V. And with this potential difference, or the potential V, now each capacitor will acquire the charge according to its capacitance. If it is of a good capacitor, if it is good capacitor of large value of capacitance, it will acquire more charge. If it is, its capacitance is less, it will acquire then the less charge. So charge which acquire, it depends the capacitance of the capacitor. So let me call Q1 the charge coming to C1 capacitor, plus Q, and let I put the symbol small q, Q1 here and minus Q1 here, like that. This will acquire Q2 and minus Q2. This will acquire Q3 and minus Q3. Now just notice from where the Q1 and Q2 and Q3 they are coming. They are coming from the potential V. The total charge which is coming is Q. When Q is coming, it is distributed into the three parts, but the magnitude depends upon the capacitance. So Q is divided into Q1, Q2 and Q3. So we can say the Q is the sum of Q1 plus Q2 plus Q3. Right? Now you know well our relation between Vc and Q. Q is equals to Vc. Now substituting the value of Q here, okay, that it is first Q1, it is having capacitance C1. C1 V, but V is the same. Remember, V is same across each capacitor. So Vc1 plus Vc2 plus Vc3. And the total charge is Q. and the total capacitance of the system. System means the whole system, whole capacity. So all the capacitors having equivalent capacitance, equivalent capacity, let me call it parallel CP. CP means capacitance of the equivalent capacitance of all the capacitors. And because Q is equals to C into V, V is the same. Okay. Then V cancels out here. V and V cancels out. And what we left? CP parallel is C1 plus C2 plus C3. So this is a very important relation. Capacitance of parallel plate capacitor when capacitors are connected. This is a very important relation, capacitance of the parallel plate capacitor, and it is simply the sum of the individual capacity, like it is having C1, having C2 plus having C3, like that. Okay, suppose you are having 1 microfarad, 20 microfarad, 200 microfarad, and all are they connected in parallel. What's the result? Result will be the greater than the largest value. Result will be greater than this, because summing up all, like sum becomes 221 microfarad, which is greater than the 200. Okay, so this is the derivation of capacitors in parallel.